Welcome everybody, thanks that come to that session, and here I will talk about some new API which finally appeared in Java 11. So just let's start. A couple of words about that. I love that slide. From one point of view, that slide doesn't relate it to the content of my presentation, but I love it because of that slide means I could tell you everything, what I want, without any connection with reality. It's my savior. Okay, continue. I'm working at Oracle. I'm a Java performance engineer. I was not writing that new HTTP client which appeared here. I was working on performance of that client, and details about performance I will provide on my tomorrow sessions. But right now here I just want to concentrate on new functionality and new ability which we receive in new Java. So let's consider the very simple task. We want to just load some HTML page or some other resource through the web inside our Java applications. How many people in that audience did that? Please raise your hand. Okay. How to do that using just Java? What inside JDK? It's the only way to do that. It's using quite old HTTP URL connection, write such weird code. It's not enough. I have to create my own method, read input stream. Look how that method which read input stream may looks like, for example, and etc. etc. As for me, I personally hate working with input stream. I want some more high level, and there are a lot of utilities and everybody writing that. It's boring. What if I want to post something? If I want not just download data, but I want to post, I'm creating that code, which weird. I can't understand what I want to do here, how its structure should be. I should know the details. It's really awful. What a typical Java developer will do in that case when he's stuck here? What you will do? Google or Stack Overflow. Okay, I'm going to Google, just Java HTTP client. I've got just from Google result 184 million Google pages for that. How should I pass through that stuff? How can I choose which HTTP client is better, which is supported right now, which is not supported, which of them just working with HTTP 1.1 version, which support new HTTP 2 version? Whatever, it's total mess. Of course, if someone in your company did that before you just use his or she findings, fine, you have some standards. But sometimes it could be not obvious idea what you want to use. Of course, if you need some fine-tuning, some etc., you know some solution. But in case of just a basic, simple task, it's not so easy. So that is why we are in Oracle developed a new HTTP client which should replace old HTTP URL connection and provide some new abilities, some new functionality to work with that. So here is that. Here is a new code, how it looks like in Java 11. So what we are doing? First of all, there is a new entities client. URL connection works with just a connection, no client, no etc. You have to create everybody for itself. You have a very nice structured code how to make HTTP request. There is a builder, classical builder. You just put whatever you want, what you need to make a request, and you are doing that kind of request. Just send, got a response of some kind of type, tells that I want to get that response as a string. I am processing status code and provide results. Is that looks better? It's not look definitely shorter because of it's again the same page inside the presentation. But from my point of view, it looks like more structured. It's not an end. Let's check what else can be done. First of all, I have do something like that, capture error processing inside of my Lambda. Don't do it outside, and don't. In that example, I won't load any kind of server response if I don't need it. I don't care what happened. I just know that in case of OK, I need to load my resource. In case of bad thing, I don't want to show that in that example. And the other ability which new client, like as an example, shows you, it's a asynchronous way. I may send asynchronous request. I may get just a completable future. Don't care when it will be finished, just to chain all desired actions here. And finally, it looks like here. And I've got the same results as before. So functional style, asynchronous style, and lambdas are making code a little bit shorter, but much more readable, I think. Why we definitely need to create such kind of client? First of all, it's just a short timeline when different things related to HTTP protocols were invented. So, URL connection, it's a class which exists since Java.0. HTTP URL connection is a class which was designed in Java.1, 1.1. It's very, very long time ago. And the significant problem is that, for example, if HTTP URL connection were released in parallel with first version of HTTP 1.1 standard, but in 1999 it was updated HTTP 1 standard, which solved a lot of issues from original situation. We can't change API at that moment. In Java, if you publish some API, it's frozen forever. You could add something, but you can't change, you can't remove anything from that. It's an issue. Of course, there is deprecation process, but it's very, very limited. And the final shot, the final kill for all that, it was the appearance of HTTP 2 protocol, which definitely new protocol, which it's from one point of view, it's new, from other point of view, a lot of things preserved from previous HTTP, but it definitely can't be fit in just old interface. And necessity of new API was obvious. Not only because of HTTP is changing, but because of Java is changing. We start everywhere using asynchronous programming. New Java features appeared like lambdas, functional interfaces, etc. So it's impossible to fit everything that into all the API. Just we decided not to drop it, just leave it as is, and create a new HTTP client. And we started HTTP client, at least a discussion 3 years ago. I'd say not 3, 4. First release of that API were done a year ago, but it was an incubator. Who heard what incubator in Java right now is? Okay, a short discussion. HTTP client, a year ago, it was the first module which appeared in so-called incubator mode. Incubator is a thing which we want to share with community. We want to show you. We are working on that. But it's still not standardized. We don't have a final conclusion about how API should look like. But we want to talk with you. We talk with community, talk with Java developers, talk with every users. And we have to get some way to show it. That is why in Java there is incubator. It could contain different features, different modules, different APIs. And API libraries, modules, whatever, in incubator could be changed. In contrary with all other Java API, it could be changed in the future. It's a goal of incubator to share, to play, to discuss, to take a feedback. So we were taking feedback for a year, for 2 versions. In Java 10, HTTP client still were living inside an incubator, but API were slightly changed. And right now, again, we changed the API, but right now it's standardized, fixed, and goes to normal JDK. Which goals we have here? First of all, the goal, it supports HTTP2 protocol. It's demand for our time. Also, it's support for asynchronous data processing because of it's very, very popular right now. It's mandatory, I think, for any kind of new Java API which appears, and to make it more convenient, and etc. etc. Just it's the single slide which I have about HTTP2 itself. Should I show some details about HTTP? But from general point of view, from the very top point of view, HTTP2 protocol is look like the same as HTTP 1.1, the same request, same response, same error codes, same order of responses. But all transport layers, not transport, but all what beneath that situation is changed. The protocol became binary. You don't need to create a lot of TCP connection for your server. There is only one connection, and all requests are split into frames and feed into that connection, etc., etc., etc. There is only one HTTP2 sync feature which required additional syncs in public API which doesn't exist in API, for example, which working is HTTP 1.1. It's server push. Also very nice feature. If you are requesting file index.html and server knows that index.html required that image, that script, etc., server initiates sending that data to the client without client request. And client may take decision to accept it, store in cache, or do whatever HTTP client wants. And it significantly should improve loading, data loading pages, and all other things. Okay, so in our HTTP client, we support both protocols. We support HTTP 1.1, we support HTTP 2. API, which is working with both protocols, completely the same. Only one method is different. I'll show that. And that's very convenient. You have some code, you test it with 1.1 HTTP, just change a version, I want to work with HTTP 2, and everything is fine, you shouldn't care about that. Let's move to client. As I told, client appeared in Java 11 as standard. You require to use module java.net.htp, and it's our package, like all that information here. And what are inside client? Inside client, there are three main classes. There is client itself, there is HTTP request, and HTTP response. It's almost everything what you need to know to work with that. Of course, I will show all other interesting things. And HTTP response is generic. You could provide any type of data if you want to. You want to respond as byte array, you got it. You want to respond as string, fine. You want to do something custom like JSON, you have ways to write, to implement all that things. It's the way as create a client. Everything in some client itself is immutable. It's look like immutable. Of course, it has internal state, but you don't have any methods of client which change state behavior of HTTP client. Everything what you want, you should specify at the moment of its creation with builder. And if you wish, you may create couple clients in parallel at the same time. It's okay. And there is a list of all methods which helps you to configure client. It's not a big method, but it's probably a lot of what you need. You may stop timeouts, you may stop authentication, cookies, SSL context, proxy, etc. The last method version just not force your client to work with particular protocol. It's setting up desired protocol which you want to use. client and server may do different agreements because of you may want to work with HTTP2, but server said, I don't want to do that. Okay, your communication continue with HTTP 1.1 protocol. And because of our client is asynchronous, it provides you a synchronous request, it's just mandatory for configuration to have a way to set up an executor for all that asynchronous stuff which are going to execute. Of course, all things have a default values, but for more fine-grained control, you may install an executor here. And the same way, the same idea of builders may be used for requests. Request also, you specify in URI, methods, timeout, versions. That's all. And of course, we may put headers for our requests and different methods for here, like delete, post, put, etc. That's all what we have to create a request. The very nice feature that request, again, HTTP request is a mutable class. Once you create the HTTP request, you could send it several times. It will be just different requests. You shouldn't bother about that. Continue. The key question, if you want to send some data to the server, how we provide our data here. For GET request, we are not sending anything. I mean body of request. But for push, post, we need to provide something. Here we should provide something that is called body publisher. We'll talk about body publisher a little bit later in details, but if you don't want to know what it is, this is a list of default body publishers. You could write byte array, several byte arrays, file, input stream, string with char set encoding. You could just write into that. You get body publisher, and you shouldn't think how it works beneath. Fine. Okay, let's talk about about HTTP response. There is no way to create your own HTTP response. It's interface. And what you can do with that interface, you can get a body, and the body has a type which we want, which we created through our publisher. We can get access to headers, status code, and all other a little bit auxiliary information. And the only way to get a HTTP response is just to send a request. A send request could be sent by two ways. As I told, it's a blocking request sent and asynchronous request. In case of asynchronous request, you didn't get HTTP response, but you are getting a completable future around HTTP response. Who here is knowing what completable future is? Guys who didn't raise hand, and if you're writing on Java, it's a big, huge gap in your knowledge. I just strongly force you to read something about completable future, to see some presentation, like Venka did a very nice presentation about that. It's a very cool new API, also appeared a couple years ago in Java, which allows you to do a very nice things, but unfortunately it's out of scope, that presentation. As for me in particular, I love it and I frequently use it for my routine tasks. Okay, and how we are receiving data. For receiving data, we should provide some body handler. It's body handler, just do something beneath, provide, read all data of that request and give you what you want. And again, we will talk about how body publisher or body handler works at the end of the presentation. But if you don't want to know details, here is the beginning of the list of default predefined body handlers. Just discarding just nobody. I don't need it. I don't want to read it. And it's not read and discard it. It definitely won't read it from a network. just cancel, drop request. You may replace something fake value, you make a string, and with bytes array, you could put result directly into file, and don't worry how it's done. And a little bit control, you may control buffering about that network interface, just if for performance and whatever you want. Everybody know what buffering is. And this is the only method which exists in HTTP client and which has no meaning for HTTP 1.1. It's sync with 3 arguments. That method is designed to process HTTP to request push promises. It looks like the same classical send asynchronous like request, body handler which should provide fast results, and additional push promise handlers. Because of here I got several files, several responses from a server. I should do something with that. And shortly again, I won't show examples, but that push promise handler is a function, lambda, functional interface, which you have to implement. The idea of that interface is the following. HTTP client gives to your function 2 requests. It's initial request and request for that particular push promise data which you're receiving, and some function which called acceptor. And first of all, your code, have to make a decision. Will you accept that push promise request from the server or not? It's a feature. If you don't want to accept that push promise request, you don't want to download that file. So I just want to index .html. Why your server giving me that G file, get and that? I don't need that. Okay, if I don't need it, I don't do anything. I don't invoke that acceptor. If I want to do something with that response from a server, I could understand what is it looking into push promise request. I have to invoke that acceptor. And if I invoke function in that acceptor, it means I will accept it. Okay, client will do everything. What I have to do when I invoke in that function, I have put into that function just my body handler. Okay, I'm accepting that push request. Here is a body handler which will give me processed data. That's all. As a result of that function, I'll get a completable future and could do with that completable future anything what I want later. And there is a static method factor. It's default implementation, one single default implementation for push promise, which accept all push requests and put it into a concurrent map, which you provided here. And in that concurrent map, you could find by request result completable future of all pushes which you got. Okay, so what we have? It's a picture. We have a data. We wrap data into body publisher. We have URI, additional parameters. We wrap everything into HTTP request. From other side, we have to provide a way which parse the data, extract data, give data from the server to us. It's done by body handler. Body handler also depends from other class body subscriber, but again, if you don't need details, you may don't care about that. We put in our client called send or send async, and we got HTTP response, and we could get data from the HTTP response. That's all. It's a raw picture. Everything is done here. Okay. A little bit several steps outside of. There is a classic producer-consumer scheme of processing data. If we have producer, we have consumer, we have some kind of queue between them, and producer put data inside that queue and consumer takes it. What's the problem with this? Have you ever heard anything about reactive programming? Reactive. The key, there are a lot of problems here, definitely, because of queue may be overflowed, or queue may be empty, Producer may stuck with that, consumer may stuck without data, it's called back pressure stuff, etc. For example, consumer failed and the producer don't know at which moment consumer failed, and whatever we can do. There are a lot of issues here, and all issues here are raised because of producer and consumer don't talk to each other. They don't communicate. All problems of classic producer-consumer scheme, they appear from the fact that producers don't communicate with consumer, consumers don't communicate with producer. They have some place, just taking and pushing, but it means nothing. It's no discussion, and without discussion, everything has a problem. That is why the reactive processing were invented. The idea of reactive processing forces them to communicate. And how will they communicate? So, starting since Java 9, we have such interface Java util concurrent flow. It's just interface which has three other sub-interfaces like publisher, subscriber, subscriptions. It's not a way from us, from Java, to suggest something definitely powerful like reactive, etc. There are a lot of different reactive third-party libraries, frameworks, a lot of them. And first of all, we as a Java's community, we shouldn't fight with them, we shouldn't force them to invent something ourselves, something our own implementation. The best idea is to provide a way to make everything works together. That is why that new interface were designed with discussion in community and suggested as a point where all different reactive stream implementation make join. Interface existed since Java 9, but till before HTTP client were done particularly no usages inside Java JDK code existed. So a little bit how it works. So we have, instead of producer and consumer, you have a publisher and subscriber. Also, publisher has a subscription, because of publisher may have different subscriptions to different providers and other things. So, and they communicate. First of all, they communicate on subscribe. They starting talk. And publisher subscription won't push any data into subscriber until subscriber asks them about that. They request. I want 1 item, I want 10 items, I want max integer items, etc. And subscription gives that items to subscriber. Not more than subscriber requested. There is other ways for communication, like provide information about error, or subscriber may tell to publisher that, oh, I did everything what I want. I don't need more data. Don't push everything to me. Just cancel. We are done. Okay, and publisher may say, okay, I pushed all data to you. We're done. It's the basic interface. So, and right now, just think what we have originally is first ideas. HTTP client send data to the server, and after that, in parallel with that, whatever, HTTP client receive data to the server. Does it make sense to rephrase it in that way, that HTTP client publish data to the servers, and HTTP client subscribes to data from the server? It's a very simple step to switch from sending to publishing and subscribing, but it's hard to do it. And our guys who were implementing that API did a very nice step. They did it. And after that, you understand that you just may use existing interfaces for reactive programming, and it will give you all flexibility which you need. It gives you ability to use different other third-party libraries for publishing and processing data. So what we have? Publisher. Publisher is someone who gives data there away. Inside HTTP client, there is a body publisher. Body publisher, it's a little bit extension of our standard default flow publisher around byte buffers. Everything is byte buffers in network. Okay, that addition is very simple. It just tell a content length of our data for optimization. Don't evaluate it. Of course, it could be -1. The subscription to data from the server a little bit different. You don't have direct first step to make a subscription and put it into that. Because of initially in HTTP2, we get a headers, a response header, and we may decide to process it differently in different situations. That is why at the top view in your HTTP client, we give so-called body handler. A body handler, it's a very simple thing. Body handler should, may or may not, whatever it wants, read initial response info, first details of response info, and according to that, body handler may choose required and desired subscriber. Like I did in the first example, I check a status code. If it's 200, I provide a normal subscriber which read the whole data. Otherwise, I don't care about error. I just discard everything. And the response info, which you could choose for making decision about that, is quite simple because of not a big information here, just a status code and all headers which we have here in HTTP2. And let's back to subscriber. It's body subscriber. It's flow subscriber from Java util concurrency library. A little bit different that it accepts not a one byte buffer, but a list of byte buffer. It's whatever it means, but that list considers a single item. And the final stage, when everything is done, we should provide a synchronously return a body of our request wrapped into completion states and completable future interface. I think it could be more clear if I'll show short example. Just a very artificial task. I don't need to download data anyway, but I want to check integrity of my data on a server at some moment. How I check in integrity? MD5. I have to check and evaluate MD5 for files which are there and, for example, compare it with my original base or something else. Doesn't matter. But I have URL, I have resource, I have to download it, and as a result, I want to get MD5. It's how can I do that? I just give me a byte array, the whole byte array, what I'm loading, put it into message digest, and get the final digest as the MD5 soon for that results. What's the problem here? The problem here is that as a result of that requested body handler of byte arrays, I will receive byte array which contains the whole file from that server, the whole resource. It could be quite large. It could be significantly larger than your heap size. It not will work slowly, but it may not work in some situation. At the same moment, we know that message digest don't need the whole data to do encryption to MD5 soon. You can put it by portions, just some bytes, another bytes, etc. It's possible to do that. So we want to make and implement such kind of body subscriber which won't collect all data, grow on final byte array, but just calculate our encryption and our MD5 sum internally in the process when we are getting data, and that's all. So what we need, if we want to create our custom MD5 subscriber, we have to implement that interface. That means that we need to implement that 5 methods. Get body as a result, it's our methods into body subscriber, and 4 methods on subscribe, on next, on error, on complete is methods inherited from Java util concurrent flow. Okay. Let's start. I need particular 3 fields in that class which implemented. It's digest, of course, which will do MD5 calculation. I initialize it in constructor. Subscription, which I receive outside. I have to communicate with the subscription. Is a subscription, and I have to get the data to work with that subscription. And here is a year in that example. Oh, no, it's okay, it's fine. And of course, I need a future to work with that. A little bit details about future or completion states which we are getting here. It's intentionally, there is no any particular ordering for that method in terms of division between getBody and all other methods. There is no guarantee that getBody will be invoked after onComplete. It means that it's asynchronously. It could be invoked before that. It's completable future. So the only way to properly implement it, not do anything, not perform any kind of action inside method getBody. Just you created future. It's initially here in constructor. It's incompleted future. We do it. After that, in getBody, we return that future. It doesn't matter was that future completed already or not completed yet. We're just giving that future that allows to all chaining actions and all stuff around that. What we are doing on subscribe? On subscribe, we just saving our subscription we received, we communicated, and we're requesting items from our subscription. I requesting just give me 1 item. I could request 10. I could set it unbound and just put a max long here. And that means, hey, publisher, you're supposed to push me everything. Don't wait it. Here is on next. On next, here is the methods when I received actual data. What I have to do it? I just have to feed all data to our digest and to request next data. Initially I requested 1 item. It means that after next item I should request another 1. If I requested at some moment 10, I have to do some calculation, or maybe not. It doesn't matter. Anyway, that I have to request. If I processed all previous requests which I did for subscription, I need somehow to allow publisher to move later. On error, it's also obvious. Let's put our error to completable future and allows the user to deal with that later. And the final method, onComplete. What we are doing on complete? We are getting our MD5 sum and put it into future completed, and if already actions change here, everything is done. And here is how it's code. We'll look using our custom subscriber. No issues. Just we don't need, and the key feature, we don't need to load the whole file to get just a short amount of bytes. In general, everything what I want to tell you about HTTP client, it's very small, very nice, very powerful API, but for some guys who want to deal with advanced configuration, we have what? We have properties. A lot of things in Java have properties, how to configure it. Here is a list of 5 properties which, if you are working with HTTP2 protocol and HTTP2 standard, you may know them. Because of in HTTP2 client and server, they communicate. Initially, they do communication exchange about settings, settings frames, so-called HTTP2 things, and that are direct values for that HTTP2 settings, which our client will send to server. And if you don't satisfy with values which provide by default, you just could change that values, just properties, and it will be. We extended size of header tables. We extended window size because of it provide better throughput. But some parameters okay. And there is a little bit other properties which may be used for configuring HTTP client. Here's the meaning. Some of them has meaning only for HTTP2 protocol, some of them for both, some only for HTTP 1.1. And again, I suppose guys who's working with HTTP stuff should be familiar with that names. I don't want to spend last 5 minutes for that. So, do you have any questions? Yes.
Previously, you had a default SSL context, and when you created your HTTP client, you could enter a SSL context. Is there any way to set a global SSL context that would be used whenever you created a HTTP client? With this update? Here, you have SSL context. Would it read in the default SSL context?
It's so it should be implicitly obtained from somewhere. What are you suggesting? Default SSL context, any kind of default value. It means that it's stored somewhere beneath. Nobody knows where it resides, and you are taking it from that. So it's Java code. It's better to do it explicitly, from my point of view.
What if you want to do it in a global scale, so not every client has to handle this?
No, no. It's the only way which you can do it. You just use it as a parameter for builder explicitly.
But with the old system properties, JavaX.NET SSL trust store and key store we used here. For example, you are connected to an HTTPS site.
A trust store and other ways they're creating for creating a SSL context. But here you just already have a SSL context and give it here. It's just different situation. Everything what related to proxy, to SSL context, SSL parameter is unchanged, and it's outside of HTTP client. It's outside of that API. It just we are using what existed before. Multiple requests, what do you mean? Here is the HTTP request builder. Here, I build a request. I could perform that request several times, and it up to server to give me the same result or not. What? Okay, sure. I don't remember details, unfortunately. Sorry guys, I don't remember details right now. What? Yeah, I know. I try to remember what it again. I don't know answer. Sorry. Yeah, I know, but I think I will turn off everything and just yes, sure. Yes.
How nicely does this play with JAX RS server side? Is it completely orthogonal, or are there any kind of subtle things, any gotchas?
It's completely orthogonal. It's just it's what inside that HTTP client, H2 standards, HTTP1, and HTTP2. If you find in the HTTP2 standards the word JAX, is the way how we'll do that. I didn't read HTTP 1.1 standard, unfortunately, but I perfectly well read HTTP 2 standard, and I don't remember the word JAX inside. Sorry. Yeah. It's quite interesting question. How we should measure that? Tomorrow I will have a session how we speed up that particular HTTP client. It won't a session about how to deal fastly work with HTTP2. It's different. The goal of my tomorrow's presentation is just to show how performance work organized. Just for example, just live show how it was done because I had request for such presentation. Not about HTTP2 details or some performance methodology in general, but just a live example. And I'm using that client because of a very nice example when a large piece of code were written from scratch, and from scratch it was optimized. And what I found in that situation, first of all, the goals for performance optimizations. The goals for performance optimization, particularly for client, wasn't achieved to high super pooper the most fastest client in the world. The goal particularly means the following: we have to achieve a reasonable performance with reasonable efforts. That is why we didn't do very extensive and aggressive tuning. We did reasonable performance. I'd rather say it comparable with all kind of clients. And what I realized inside that, working with that client, first of all, you can't beat HTTP 1.1 protocol if you're measuring on local host. If you're benchmarking on local host, HTTP 2 never can beat HTTP 1.1. Because of HTTP 2 was not designed for local host. At the same moment, we were tuning with reasonable efforts. We are tuning our Java code. And mostly our things were measured on local host. That's all. We just didn't compare that. Because in case of non-local host, it's issue not around your Java code, but a lot of issue inside network connection. It's outside of JDK. It's tuning TCP connection, etc., etc. Again, not the same task. So, is it better than, it's faster than HTTP URL connection? No, because of HTTP URL connection uses 1.1 Java. 1.1, HTTP 1.1. And for local hosted video. For non-local host, the performance of that not inside Java code, it's inside how the overall stack and network is configured. So that question was out of scope. Any question? And I'm definitely sorry about some details which I missed for HTTP itself. As I told, I'm a performance guy, not in networking.